We're going to look at problem solving, and we're going to be using permutations. Actually, this is more factorials. I should really change this title. I'm going to call it factorials, okay? Though it might seem like permutations. It's a funny way to start a video, changing the actual titles. But anyways, let's read our question. The question is, how many different ways can you arrange the letters of the word think so that the T and the H are separated by at least one other letter? And the word by at least one other letter is really important, okay? So what I'm going to do is I'm going to use some words kind of in a math equation. By at least one is really tough to work with. There's so many different ways because you can do at least one letter separate. So for instance, we could go T-I-H-N-K, right? There's that option, and that's separated by 1. Or we could go T-I-N-H-K, that's separated by 2. Or we could go T-I-N-K-H, or separated by 3. So there's already 3 different categories to research. What I think, and this is used a lot in probability with this course, data management, what we can do instead is let's look up the total number. So I'm going to find total number of arrangements. I don't know if I spelled that right. Okay. Total number of arrangements. And what I'm going to subtract is when they're together. Okay. So we're going to subtract when T and H are together. Okay, and the reason I'll do that, see how we said we had 1, 2, 3 different ones to do the research on, and there's a lot of different options for those. What I'm going to do is total number of arrangements, and then when T and H are together, well, that's like T-H-I-N-K, and we can just treat that as like a letter. Okay, so let's do total number of arrangements. Okay, well, we have the word think, and all the letters are different, so the total number of different ways we can arrange that is a factorial. So think of it like 1, 2, 3, 4, 5. You have 5 options. You could put T, H, I, N, K. Okay, and then from the first letter, you then have 4 options. Okay, you'd have the H, the I, the N, the K. If we take the T root, then you have 3 options. Okay, then you have 2, and then 1 option. In other words, you have 5, 4, 3, 2, 1, which is also known as 5 factorial, right? That's a total number of arrangements, which kind of makes sense with what we're doing. Okay, so 5 factorial. And 5 factorial is 125, or is it 120? I think it's 120. Let's bring up our calculator, double check. 5 factorial. Okay, 120. Great. So there's our first category. Okay. The next thing we're going to do is with the word think, we're going to do when they're together. So instead of writing the word T-H-I-N-K, they have to be together. So I'm going to replace this T-H. Let's just call it the letter A, okay, to represent both of them. Because they have to be together, so it's got to move around like the letter A, which then means we have A-I-N-K, okay? And A is representing when T and H are together. So now there's only 1, 2, 3, 4 letters to work with, okay? So in other words, how many ways can we rearrange these 4 letters? Well, using the same method we did before, it would be 4 factorial, right? Because there's 4 different letters. So when we do 4 factorial, 4 factorial gives us 24. So there's 24 ways we can do that. Is equal to 24. Now we said in our equation above, we're going to take the total number of arrangements and subtract when T and H are together to figure out when they'd be apart, okay? Because that would only leave the option of when things are apart. So we would do 120 and subtract our number 24. And that equals, we'll do that in black, that's actually going to equal 96. So we have 96 different arrangements when we go about it this way.